In this lesson, we're going to be talking about rate of change. We're going to be relating rate of change to slope. By the end, you should be able to find rate of change in the context of real-world problems. As we talk about rate of change, it's important to bring up its relationship to slope. So let's review a little bit about slope. If you recall, slope tells us the direction and the steepness of a line. And there are four different types of slope that we could have. We could have a positive slope, we could have a negative slope, we could have zero slope, or we could have undefined. When we talk about positive slope is slopes that slant up and to the right. So they slant up and to the right if we're looking from left to right. And both the numerator and the denominator will be positive, or both the numerator and the denominator will be negative. Either case, you'll have a positive slope. When we talk about negative slopes, these are slopes that slant down and to the right. So for negative slopes, they slant down to the right, like we have here. And either the numerator or the denominator will be negative. So either the top or the bottom will be negative, or the negative will be pulled out to the front of the fraction. So if we're looking at a graph, you're looking from down, slanting down from left to right, or one negative sign located somewhere throughout that fraction. We talk about zero slope. Zero slope talks about the steepness of our line being flat or zero. So there is zero steepness. It's a flat horizontal line. And when we're looking at a fraction, 0 is going to be in the numerator. And when we talk about undefined, undefined is a lot like zero slope, but it's the opposite. So instead of a horizontal line for undefined, we'll have vertical, and instead of 0 being in the numerator, 0 will now be in the denominator. Okay, let's talk a little bit more about rate of change. So rate of change is the real-world application of slope. So it's the same thing as slope, but now we're looking at it in the context of real-world problems. So it tells us, rate of change is telling us how one quantity changes in relation to another. And typically it's going to be a change in a quantity over a change in the time, where the quantity is dependent, that's the y, and the time is the independent, that is the x. So that's along the x-axis. When we're finding slope, recall zero slope, just to review, from a graph will be a horizontal line. When we talk about from a table, the table is going to have all of the y values being the same. If we're writing an equation for a horizontal line, it's y equals and a number, wherever that number crosses the y-axis. And when we're looking at from words, the dependent quantity will remain the same. It's not going to change. So when we have a constant speed, speed is the dependent. That constant means it's not changing over time. We like to use a little acronym here, a little mnemonic device called HOI. This helps us kind of remember our attributes of a zero slope. When we think about HOI, it tells us horizontal line, zero slope, and a y equals equation. When we talk about undefined slope, we like to use the acronym of VUX. V standing for vertical line, U standing for undefined, X standing for x equals equation. And for undefined slopes, it's the exact opposite from 0. So for undefined, we'll have a vertical line. In the table, the x values will be the same. Our equation will be an x equals equation. And from words, it's the independent quantity that's going to stay the same. And this would be when we have two quantities compared to each other, such as the number of questions on your algebra test, which is always 20. That's not changing. That part's staying the same. But the dependent, which is your grade, is changing. Okay, let's look at a couple of examples. If we look at A, we're looking at a graph. If we see that there's a horizontal line, then I don't have to do a whole lot of work here because we know that all horizontal lines, if we remember HOI, have zero slope. So this would be a zero slope. If we're looking at our, if we're looking at the 2 points, remember that we can use the slope formula. So if we substitute in our values, remember we need to define an x1 and a y1. It can be either point, but just be consistent. So my y2 is 1, my y1 is 4, my x2 is negative 2, my x1 is also negative 2. 1 minus 4 is negative 3. 2 minus a negative 2 or negative 2 plus 2 is 0. And because 0 is in the denominator, this would be an undefined slope. And so we would write undefined slope. When we look at from finding rate of change from a table, okay, it says the table below shows the number of students who majored in biological sciences from 1990 to 2000. Rate of change is the same thing as slope. So remember, we can look at the change in y compared to the change in the x's. My y is my dependent, my x is my independent. Change in y, that's plus 6, plus 6, plus 6, plus 6, plus 6. So change in y is 6,000, right? And then my change in x's is every 2 years they're looking. So 3 over 1, or 3 if we simplify, and that's 3,000. So make sure you're reading the units that are there. 3,000 students per year. So there's an increase of 3,000 students per year who majored in biological sciences. When we're finding things from real world situations, it's important for you to remember, for you to keep in mind that we want to go back and write it in words. If we're looking from here to here, from x to y, we're looking at change in x, that's 2. Then this is plus 3, and that's plus 4. We're looking at change in y's, which is minus, I believe 9, and then minus, would give you negative 13.5, and then from negative 10.5 to negative 28.5 gives you negative 18. Now, even though all of these changes are different, remember that they're different along the x's and along the y's. Their ratios, if it's linear, should still be the same, and in this case it is. Your change would be negative 9 over 2. And I would leave it. It gives you a decimal, so you could change this to a decimal. You could say negative 4.5. But I would leave it as the improper fraction, negative 9 over 2. But because they gave you decimals, this would be the one rare occasion where you could go ahead and change that fraction to a decimal. We're finding from a graph, again, rate of change, same thing from finding slope. So we're looking at vertical change to horizontal change. You need to pick 2 points that are along the graph. So here's 2 points that I can clearly see. Make sure that when you're finding your change in y over change in x, that you're keeping the scale of your graph in mind. So here we are decreasing. Our scale is going by 5, not by 1. So I'm not counting 1, I'm counting minus 5 here. So from 10 to 15, or from 15 to 10, that's a decrease of 5. And then my increase is going by 75. This is my scale here. So as I go from 1 to from 0 to 75, I'm increasing. I have a positive 75. And so if I simplify that, that would be negative 1 over 15. And then we want to keep in mind that it's y over x. We want to keep those units. So this would be negative, you're decreasing, you're losing a 1/15 of a gallon every mile. So per mile. So make sure that you keep your units. Again, the y unit comes first, and then the x for the per part. If we're looking at B, we're looking at the amount of gas that's being used, the volume of gas being used as the temperature increases or decreases. Send the page a little bit. There we go. All right. So here we're doing the same thing. We're looking at our scale. We need 2 points. I would pick 2 points. So 2 points that are a little bit easier to read. So we'll make that a point. I'm not entirely sure if that's a point that's on there. And then we'll use this point. Again, pick easy points to read because as you're climbing, as we're finding our change, I know from here I'm going from 25 to 30, so that would be an increase of 5. So my change in y would be positive 5. My change in my x's, I'm going from 40, and I'm ending up at 100, so from 40 to 100, that would mean that my change in x is 60. And then I could simplify this to 1 over 12, 1/12. So we're increasing a 1/12 of a milliliter per degree Celsius. So again, keep those units in mind as you are finding your rate of change. From word problems, Mark is moving across town. He rents a trailer for his belongings the first day. Cost him $25. Unfortunately, he does not finish in one day, and the cost for 2 days is $45. So if we're looking at rate of change, we know the first day is $25. At that point, it would be $125. The second day is $245. For 2 days is $45. So if we find our change in y, we're changing x using the slope formula. We have 2 points here. So my x2, 40, my y2, 45, my y1, 25, my x2 is 2, my x1 is 1. I could flop those, okay? 45 minus 25, that's a change of 20. 2 minus 1, which is 1. So we're increasing $20 per day. If we're looking at number 5, we're given an equation. We have 3.75 plus 1.5x minus 1 can be used to determine the cost of taxi in dollars. What is the rate of change? So here we have an equation. Remember, our equation is y equals mx plus b. So I'm going to have to simplify this 3.75 plus 1.5 x minus 1 so that, I gave you the answer there, but so that we can find that slope. So here we distribute 1.5x minus 1.5, 3.75. We could combine like terms here, so if I subtract 150, this would be 2, and then 225 plus 1.5x. That would combine those. And then we're looking for the mx part. That would be this part right here, and the slope would be 150, 1.5, and be 1.5 dollars per mile. So $1.50 per mile. We're looking at 6. It says Eli burned 1,449 calories running a half marathon. If he finished the race in 2 hours and 6 minutes, how many calories did he burn per minute? You're taking 1,449 and you're dividing it by 2 hours and 6 minutes. We want to change the 2 hours to minutes, so 2 hours would be 120 minutes plus the 6 minutes. And we were taking the unit rate, so you would divide the number of calories by 126 minutes, and that would result in 11.5 calories per, or 11.5 calories per minute. Same thing here for looking at Jade can read 324-page book in 12 days. Well, it took Mindy only 8 days. How many more pages a day did she read than Jade? You would find their unit rate per day. So 324 over 12 days would give you the page per day for Jade. 324 over 8 days for we give you the one for Mindy, and then you could subtract those unit rates there. So 13 pages, 13 and a half pages per minute more would be the answer there. Okay, the 4 different types of slopes are and they look like. So what are the 4 different types of slope that we have, and what do they look like? This is what I would like for you to consider before watching the next video.